So we are going to start with chapter 8, and we are going to look at right triangles, and we'll get a little bit of an introduction to trigonometry. In this chapter, you may have noticed on the lesson plan it says that we need you to have calculators for every lesson. That's going to be really important when we get to the lesson on trigonometry, when we get to that, learn about some of the basics with trigonometry. But first we're going to focus on 8.1, and 8.1 is on geometric mean. So when you were back in algebra, or maybe even pre-algebra, you learned about mean, but it was the arithmetic mean. So the mean is like the average of a set of numbers. However, geometric mean has to do with the proportion A is to x as x is to b. So for two positive numbers, a and b, the geometric mean is the positive number where x, where the proportion a over x equals x over b is true. So by cross multiplying, you'll see that we get x squared equals a times b. So x is going to be the square root of a times b. Now, in this lesson, we're going to, whenever we have a square root, we're going to look at reducing it versus just typing it into our calculator to get a decimal approximation. I know on the homework it may say to round to like the nearest 10th place, but I would prefer you to simplify your answers or reduce the radicals. Okay, so take a look at the first example. Find the geometric mean between each pair of numbers. So I'm actually going to go back to this formula and use that just so we get used to it, because when we apply some of the theorems later on, that formula will be important. So we're going to put, as soon as you see geometric mean, as soon as you see that word, whatever is the geometric mean, we're going to put that in the two spots. So x is the geometric mean between 4 and 9. And honestly, it doesn't really matter where you put the 4 and the 9 as long as they're diagonal to each other. So we cross multiply, we get 36. And then when we take the square root, we get x equals, now normally this would be x equals plus or minus 6. However, notice here it says positive numbers, so we're going to have a positive answer for these. So we do get x equals 6, and we didn't have to really worry about reducing any radicals in that case, and it was just square root of 36 was a perfect square. So let's take a look at the next one, 6 and 15. So x is the geometric mean of 6 and 15. X squared equals 90. So when I take the square root this time, you may remember we did that one of the last lessons in the last chapter. We practiced reducing radicals. So the largest perfect square that we have is going to be 9. So we have 9 times 10. I think this is 9 times 10. So square root of 9 is 3. So we have 3 for the square root of 10. Next one, we have 6 and 2/3. So again, we have x is the geometric mean of 6 and 2/3. So I have x squared. 6 times 2/3 is going to be 4. And then when I take the square root, we get x equals 2. And finally 10 and 15. So I have x is the geometric mean of 10 and 15. We get x squared equals 150. Take the square root. And the answer is going to be, so 150 is divisible by 25. That's the largest perfect square. Think 25 times 6, so square root of 25 is 5, with a square root 6. So let's take a look at the first theorem involving some similar triangles that are formed in a right triangle. So the altitude, so if you recall, the altitude is the segment that's going to go perpendicular to the opposite side. So it has to be drawn from the vertex of the right angle of a right triangle to the hypotenuse. So we're talking about this segment right here. What ends up happening is the two triangles that are formed are similar to one another and to the original triangle. So if you so let's look at the two triangles first. Let's look at triangle ACD and this other triangle CBD. So if you think about or actually let's start with triangle ABC. Triangle ABC, which is the big triangle, is going to be similar to triangle CBD and also similar to triangle ACD. If we were to kind of trace over these, we can really see. Let's just pick a different color. So here's your big triangle ABC, and let's do here's this one. So what ends up happening is they share this angle, angle A, okay? And they also have a right angle. Here's one right angle, here's another right angle. By angle-angle similarity, we know that they're similar. So we could also look at the other triangles, right? As long as they share, so here's the big triangle again. And now let's look at the little triangle on the right. They both share angle B, and they both have a right angle. So again, by angle-angle similarity, they're similar to each other. So if the big triangle is similar to this one, and the big triangle is similar to the one on the right, then all three are similar to each other.